Hello friends, today we are going to solve some GATE previous year's questions from the chapter metal cutting. So now this is a GATE question from the year 2014. First of all, we will read the question and then we will try to solve the question. So what the question is saying? The question says the main cutting force, see they have mentioned cutting force, the main cutting force acting on a tool during turning, see the operation is turning, orthogonal cutting also they have mentioned in the bracket of a metal is 400 newtons. So they have given the force FC, cutting force is 400 newton. Now what they are saying, that turning was performed using 2 mm depth of cut. So the depth of cut was 2 mm and the feed is 0.1 mm per revolution, 0.1 mm per revolution. So what they are asking, the specific cutting pressure. So what they are asking is specific cutting pressure. I am writing in small form SCP. SCP stands for specific cutting pressure, and the unit in which they are asking is Newton per mm square. So specific cutting pressure can be calculated by a simple formula, that is F by small fd, and we are given all the values, that is F is as 400, small f is 0.1 and small d is 2. So on putting all the values and calculating, we get the answer as 2000 Newton per mm square. Since the value of d is in mm and feed is also in mm, the unit which we are getting is Newton per mm square, and the question is also asked in the same unit, that is Newton per mm square. So the right answer is option B. Option B is the right answer. Now moving to the next question. So again this is a GATE question from the year 2014. First of all we will read the question. So what the question says, during pure orthogonal turning. So pure orthogonal turning, basically they are trying to say that lambda is equals to 90 degree. So what is lambda? Basically lambda is principal cutting edge angle as per orthogonal rake system. Now what they are saying, it is found the thickness of chip produced. See they have mentioned the thickness of the chip produced, which is TC, chip thickness is 0.5 mm. The feed given to the 0 degree rake angle, see they have mentioned very important data, that the rake angle is 0 degree. Alpha is rake angle because rake angle is generally denoted by alpha, so I am writing alpha here. Alpha is equals to 0 degree. And what they are given, the feed is 0.2 mm per revolution. So feed is 0.2 mm per revolution. Now what they are asking is the shear strain, the shear strain produced during the operation. So as we know from the metal cutting theory, that shear strain is basically defined as gamma equals cot phi plus tan phi minus of alpha. Since alpha is equal to 0 already given in the equation, so it will become cot phi plus of tan phi. Let's say this equation be first. So in order to calculate gamma, we should know the value of phi. So how we will get the value of phi? We will use a relation of metal cutting again, which says tan phi equals r cos alpha minus r 1 minus r sin alpha. Since alpha is again given 0 here, so sin alpha, which means sin 0, will become 0 and cos 0 is 1. So the equation will become tan phi equals r. So in order to know phi, we have to know the value of r. So what is r? Basically r is a ratio of chip uncut thickness to chip thickness. So we have already been given the value of TC. We have to calculate T. So how we will calculate T? Basically T can be calculated using the value of lambda and feed, and the relations is T equals to F sin lambda. From geometry we are getting this relation. So F is 0.2 and sine of lambda, which is sine of 90 degrees 1. So T is equals to 0.2. So we will be getting R as 0.2 by 0.5, which on calculation we will getting 0.4. So tan phi becomes 0.4. So now we will put the value of tan phi, let it be 2, in equation 1 here. Now gamma is equals to cot phi plus of tan phi, which we can write as 1 by tan phi plus tan phi. So it will become 0.4 plus 1 by 0.4. If we will solve it and put the values, we will get it as 2.9. So the right answer is 2.9. Now moving to the next question. So this is again a GATE question from the year 2014. So first of all, we will read the question. So what does the question say? If the Taylor's tool life exponent n is 0.2. So what is basically Taylor's tool life exponent? Now the simplified Taylor's tool life equation is represented by Vt to the power n equals to constants. See friends, this is a simplified Taylor's life equation. Tool life equation. So where here v is velocity, t is tool life, and n is the exponent. Now what they are given is n in this question is 0.2, and they have given the tool changing time is 1.5 minutes. So the tc is 1.5 minute. Now what they are asking, then the tool life for maximum production rate. So if you have read the theory properly, for maximum production rate, the relation which we are getting is T is equals to Tc into 1 minus n by n. See, this we are deriving it from the basic Taylor's tool life equation, and for maximum productivity, when we differentiate and equate it to 0, we will get this equation. You can also solve it, but I am not going to solve here, and we will now put all the values, like Tc is equals to 1.5, 1 minus n is 0.2 divided by 0.2, which is equals to 1.5 into 4, which is equals to 6 minute. So the answer is, they have asked, is in minute only, so it is 6. So the correct answer is 6. Now moving to the next question. See, this is again a GATE question from the year 2014, and this is now match the following question. So first of all, we'll see that in group A they have mentioned center lathe, milling, grinding, drilling, and in group B they have mentioned slotting, counter boring, knurling, and dressing. So group A basically contains machine tools, see, they have mentioned it, and group B contains operations. What kind of operations can be performed on these tools? So first of all, we will go one by one. Center lathe. Center lathe is basically used for processes of like knurling. So P is here stands for 3. Now milling. See, if you have read the theory properly, you might be knowing that there is a particular process known as slot milling. So it's very easy to guess that for milling it would be slotting. So Q is 1. Now comes grinding. See, grinding is basically a tool which is used to remove layers. So from reading all the options of group B, we can easily guess that for R grinding, that is, it will be 4, dressing. Now and for now the last option, drilling, we know that drilling is a method used to make holes, and counter boring is basically a hole making phenomena, drilling phenomena. So through drilling we make counter boring operation is done. So for S it will be 2. Now we will look at the options and we find that option C is correct. So correct answer is option C. Now I will solve it in another method, that is elimination method, which will save your time in a competitive examination like GATE. So first of all, let's say I know milling, that slot milling is an operation which is performed. So milling is for slotting. So Q is for 1. That's for sure. Now we will look at the option. See, option A doesn't contain Q1 and option D doesn't contain Q1. So these will get eliminated. Now B and C are the probable options. So now if let's say drilling, you might be knowing about drilling or grinding or center lathe, any one option you might be knowing and you will be getting the correct answer. So let's say I am knowing about drilling. So drilling is used to make holes, and counter boring is an operation which is performed through drilling operation, so drilling tool. So for S it is 2. So when we look back at the options again, we find that S for 2 is only in option C. So option B also gets eliminated. So the right answer is option C. So it will save your time, and if might be there might be a chance that you might not be knowing all the options, that for what is performed on center lathe and what might be performed on grinding or drilling. If you are knowing only two of them, you might able to solve this question very easily. Now moving to the next question. So this is again a GATE question from the year 2014. So you might be seeing that GATE has a very good tendency of asking questions from the chapter metal cutting. So I would say that metal cutting is a very important topic when it comes to GATE examination. Do prepare it thoroughly and practice more and more numericals, as you are seeing that they have asked more numerical type questions rather than theoretical questions. Now we will go back to this question, which is a hole of 20 mm dia. See, they have mentioned that the whole dia is of 20 mm is to be drilled. So this is a drilling operation, and the steel block thickness is of 40 mm. See, the thickness of the steel block is of 40 mm. Now the drilling is performed at a rotational speed of 400 rpm. So they have given the value of rpm as 400 rpm, and they have given the feed rate also, that per rotation or revolution, sorry, for per revolution, that the feed is of 0.1 mm. So feed is of 0.1 mm per revolution. And they are saying now that the required approach and overrun of the drill together is equal to radius of the drill. Now they are saying that the required approach, I am representing it as RA, required approach, and overrun as OR, which is equals to radius of the drill, which is now radius is 20, die is 20, so d by 2. Now what they are saying is that drilling time. So see, time is basically calculated by the length traversed upon the speed which it is traversing, which is represented as F into N. Now F into N will give you the time. Now we'll put the value of L. So what is L basically here? L is basically the total thickness which the drill will have to pass, which is 40 mm, plus required approach and overrun, which is d by 2, and d by 2 is basically 20 by 2, which is 50 mm. So the drilling time will become 50 mm divided by feed. Feed is 0.1 mm per revolution into 400 revolution per minute. So see, the answer which we will get will be in minutes, because it is revolution per minutes and it is revolution. So the answer which we will be getting is in minutes. So 50, 500. So it will be 5 by 4, which will be 1.25 minutes. So when we look at the options, we see that option B is 1.25 minutes. So the right answer is option B, 1.25 minutes. Now moving to the next question. So the next question is again from GATE 2014. See, GATE 2014 has asked lot of questions from machining, or I can say metal cutting. So now what the question is: a straight turning operation is carried out. See, the operation is turning operation is carried out using a single point cutting tool on AISI 1020 steel rod. See, this is a very important data. AISI 1020 steel rod. The feed is 0.2 mm. So they have given the feed as 0.2 mm per revolution, and the depth of cut they have mentioned as 0.5 mm depth of cut. Now they are saying that the tool has a side cutting edge angle of 60 degree. Side cutting edge angle as SCEA equals to 60 degrees. See, they have mentioned a very important data, which is AISI. As per AISI, side cutting edge angle equals 60 degree. So what is lambda, which is principal cutting edge angle, which is equals to 90 minus of SCEA, or it can be written as CS, that is side cutting edge angle, which is equals to 30 degrees Celsius. Now what they are asking is the uncut chip thickness. So what is basically the uncut chip thickness? Uncut chip thickness is basically given as TC equals to F sine lambda. Basically F is feed, so feed is 0.2, sine of lambda is sine of 30 degree, which is equals to 0.1. So the feed is 0.1 mm. So the feed is 0.1 mm. So this is the right answer. Now moving to the next question. So friends, this is a theoretical question, and it is again a GATE question from the year 2014. So in this question what they are asking, cutting tool is much harder than the workpiece. True, cutting tool is much harder than the workpiece, yet the tool wears out during the tool work interaction because extra hardness is imparted to the workpiece due to coolant use. No friends, a coolant doesn't impart any kind of hardness to the workpiece. This statement is totally wrong. Oxide layers on the workpiece surface impart, see, oxide layers are themselves brittle in nature, so they doesn't impart any extra hardness, they can't do that. So this is again wrong. Vibration, see, the third option is extra hardness is imparted to the workpiece due to a severe rate of strain. See, yes, this is the correct answer. Strain hardening phenomena basically takes place when tool work interaction is happening in a machining operation. So option C is the correct answer. So correct answer is C. Now moving to the next question. So again this is a GATE question from the year 2014. So what is the question saying? Which pair of the following statements is correct for orthogonal cutting using a single point cutting tool? So now what they are asking, reduction in friction angle increases cutting force. So first of all we have to know the relation between cutting force and friction angle. See, basically cutting force is denoted by Fc is equals to R cos beta minus of alpha, where Fc is cutting force, R is a resultant force, and angle is cos beta minus of alpha. It is a relation basically derived from Merchant's circle diagram. If you have read through the theory, you might be knowing this relation. So now what they are saying, where beta is friction angle, this is friction angle, and alpha as we know is rake angle. So alpha is, they haven't mentioned anything about alpha, and they are saying that using a single point cutting tool, basically alpha is constant in this case, and R is also a constant. So what they're basically asking is the impact of B on Fc. So we know, see, if they basically are saying reduction in friction angle, if we decrease B, let's say we are decreasing beta, if beta is getting decreased, so the value of cos beta minus alpha will also get decreased, and since the value of cos beta minus alpha is getting decreased, so Fc will also get reduced. So option P is incorrect. Clearly it's incorrect. Force will definitely reduce. So option Q is correct. Now the third option is reduction in friction angle increases chip thickness. Now basically they are asking the impact of friction angle change on chip thickness. So again we are knowing from Merchant's theory that phi equals to pi by 4 plus alpha by 2 minus beta by 2. So where phi is basically shear angle, we are knowing that it's shear angle. Now pi by 4 is constant value, alpha is, since the tool isn't changing, so alpha is also constant. So if beta is decreased, so phi will be increased. Now if phi increases, see, phi is increasing, so tan phi will also increase. Now phi, we are saying about tan phi, basically tan phi is R cos alpha minus 1 by R sin alpha. Since tan phi is increasing and these values are constant, So what will happen to R? R will also increase. So R will also increase. So what is R then? R is T by TC. So if R is increasing, so then TC has to decrease. So for reduction in friction angle, the chip thickness will also decrease. So the correct option is S. It will not increase. So the right answer is option D, which is reduction in friction angle will decrease cutting force also, and it will decrease the chip thickness also. Option D is the right answer. Now moving to the next question. So this is again a GATE question from the year 2014. So this is a question is two separate slab milling operations 1 and 2. So this is a milling operation and slab milling operations are performed with identical milling cutters. So the cutters are basically same. The depth of cut in operation 2, which they are saying D2, I am saying D2, is twice that in operation 1, that is 2 times of D1. The other parameters are the other cutting parameters are identical. The ratio of maximum uncut chip thickness in operations 1 and 2 are, see, for milling operation the maximum uncut chip thickness is basically denoted by relation T1 equals 2f under root of small d by capital D, where D is the depth of the depth of the cut, and capital D is the dia of the cutters, and F is the feed rate. So now what they are asking is the ratio of maximum uncut chip thickness in operation 1 by 2. So T1 by T2, since all the other parameters are constant, is a relation of D1 by D2. Now let's say this is first. Putting the value of d1 by d2 in this equation, we will see that t1 by t2 is equals to under root of 1 by 2, which is root 2 by 2, which is equals to 0.707. So the right answer is 0.707 to this question.